I'm Teacher Bella. Welcome back to my YouTube channel. In this video, I will share with you the latest syllabus of Form 5 and Maths Chapter 1 Circular Measure. Are you ready? Let's start! Hello everyone! Today I want to share with you about the KSSM syllabus Form 5 Chapter 1 Circular Measure. Okay, there are 5 big parts in this chapter. Okay, so I will share with you part by part. Okay, the first part, you have to know how to change the degree to radian. Okay, so I will show you how I change the degree to the radian. So for example, 30 degree. How can you change the 30 degree to a radian? You have to times pi over 180. So by using your calculator, you just calculate 30 times pi divide by 180, then you will get your answer, which is 0.5236 radians. Okay, in another way, if the question give you is 1.715 radian, how can you change it to degree? You have to times 180 over pi. So you use your calculator, 715 times 180 divide by pi, then you will get 98.3 degree. Okay, so in conclusion, how you change the degree to radian is by using times pi over 180. And how you change the radian to degree? Then you will times 180 over pi. Okay, this is the first part that you have to know. Okay, let's go to the second part. Okay, the second part, you have to know how to calculate the length of an arc. Okay, we denoted as S. Okay, the formula is S is equal to R theta. And you have to remember the theta is in radian form. This is very, very important. Okay, the R means radius. Okay, radius times the angle. Okay, angle of the sector. Okay, so we go to the third part, which is perimeter of the segment. Okay, so here is the segment. This shaded region is called segment. Okay, how can we find the perimeter of the segment? So there got two sides. Okay, which is this is the chord and this is the arc. Okay, so the first thing you have to find the arc. The arc, I have already shared the formula, which is R theta, and the theta here is in radian form. Okay, and then the chord PQ. Do you still remember the chapter 9 in Form 4? The solution of triangle. You are using the cosine rule to find the length of PQ, which is PQ squared is equals to R squared plus R squared minus 2R times sine theta. Now we stop here. I give you few examples to show how can I use this in the question. Okay, let's go to the example 1. The diagram shows a sector OAB of a circle with center O. Here is the center O, okay, with the radius 13 cm. Given that the BM is perpendicular to OA and BM is 5 cm. So BM and OA is perpendicular. That means here is the 90 degree. And the question tells us that the BM is 5 cm. Okay, calculate the angle of AOB in radian. So where is the angle AOB? AOB. So here is the angle, but the question wants us in radian. So how can we find? So we'll use the trigonometric ratio. Let me draw out this triangle. Okay, here is the 13 cm. Here is O. Here is B. Here is M. Okay, this triangle. Okay, so here is 5 cm. So sine, cos, and tangent. Which one should I use? Which one should I use to find the angle? I should use sine. Okay, so sine theta is equals to 5 over 13. So theta, by using your calculator, you can find the answer is 22/62 degree. But the question they ask us to find in radian, so we have to change it to radian. How can we change it to radian? You remember? We have to times pi over 180. So 22.62 times pi over 180. Then you will get your answer is 0.395 radians. Okay, so we go to the part B. This is the part A. the perimeter of the shaded region. So we have to find this shaded region. Okay, the perimeter of this shaded region. Here, let me draw out this part. Okay, here is M, here is A, here is B. Okay, so here is 5 cm. The question already gave us. Okay, BM is 5 cm. And then, how can we find the MA? So the radius here is 13 cm. So that means here is also 13 cm. Can we find the OM? Yes, we can. Okay, by using the Pythagoras theorem. Okay, the Pythagoras theorem tells us that 13 square is equals to 5 square plus OM square. So OM square is equals to 13 square minus 5 square. So OM is equals to 12 cm. Okay, so here is 12 cm. Can you know that how much is the AM? Yes, 1 cm. 12 plus 1 cm is equals to 13 cm. So now we have to find our BA. BA is the arc of the sector. Okay, so the arc of the sector, the length of the arc of the sector of BOA is equals to R theta. The radius is 13 cm. The angle we can find from the part A, 0.395. So the answer is 5.13 cm. So after that, you just plus it up. Okay, perimeter is equals to 5 cm plus 1 cm plus 5.13. So the total is 11.13 cm. Okay, so let's go to the example 2. The diagram shows a circle with center O here, and the radius is 14 cm. 14. Okay, the angle MON is pi over 2 radian. Okay, calculate in terms of pi the perimeter of the shaded region. Okay, what should we do? Okay, we have to find here is M, here is N. Okay, this shaded region got two sides. From M to N, this is the chord, and then the arc. Okay, the arc of MN is equals to R theta. Okay, R theta. So R is equals to 14. Theta is equals to pi over 2. So the answer is 7 pi cm. Okay, now we have to find the chord. How can we find the chord? Still remember the solution of triangle? Yes, you can see from this triangle. Okay, this is pi over 2. This is 14, and we have to find this line, MN. Sorry, here this is the N. Okay, we have to find the MN. Before we find the MN, we have to change this angle to degree. So pi over 2 is in radian. We change it to degree. How can we change it to degree? Times 180 over pi. So we divide this. So we'll get 90 degrees. So this angle is 90 degrees. So MN square is equals to 14 square plus 14 square minus 2, 14 cos 90 degree. So you can get your MN is equals to square root 392 cm. So the perimeter of the shaded region is equals to 7 pi plus square root 392. Since the question wants us in terms of pi, so this will be my answer. Okay? So now we continue with our explanation. Okay? So we have already finished the part A, B, and C. Now we go to the part D. This is the way how we find the area of the sector by using the formula 1 over 2 r squared theta. The r is the radius. The theta is in radian. Okay? Area of the segment of AB. There are got two ways to find the area of the segment. Okay, I'll share with you the first way. Okay, just in case the question give you the radius and the theta, the angle. Okay, so you can directly use this formula 1 over 2 r squared, which is the area of the whole sector. Okay, and then minus of the area of the triangle. This is the formula that you learn from the solution of triangle in chapter 9 of form 4. Okay, 1 over 2 r squared sine theta. Okay, so you just minus off this triangle, then you will get your area of the segment. Okay, so just in case the question give you the radius and the chord of AB, it doesn't give you the angle. No, it doesn't give you the angle. What can we do? So there are 3 steps. Okay, the first step, you use your cosine rule to find your angle first. Okay, AB squared is equal to R squared plus R squared minus 2 cos theta. Okay, and then you use your Heron's formula. Still remember your Heron's formula? Then you can find your area of triangle. So after you find the area of the triangle, then you use the area of the whole sector to minus off the area of triangle, then you will get your final answer. Let me use an example to show you, okay? So let's go to the example 3. Okay, in this question, the question gives you the angle and the radius. So since you have the angle and the radius, you can directly use this way. Okay, so you can use 1 over 2 r squared theta. How can you find the whole sector? Minus of the triangle, 1 over 2 r squared sine theta. Okay, so the area of the segment is equals to 1 over 2 r is 5 cm, r squared theta. Theta is in radian, so you have to change this to radian. 58 degree times pi over 180, and you will get your answer as 1.012 radians. So you substitute here 1.012 minus 1 over 2 r squared sine theta. This theta have to be in degree, 58 degree. So you just press your calculator, you can get your final answer, which is 2.05 cm squared. Okay, so you just find the whole area of this sector. Okay, the whole area of this sector, which is this, and then minus of this triangle. Okay, minus of this triangle, which is this. Okay, then you will get your area of shaded region. Okay, we go to another example. This example, it doesn't give you the angle. It gives you the chord of AB and then the radius. Does it give you the angle? No, the question doesn't give you the angle. So there are 2 ways to solve this question. Okay, 2 ways. Okay, the first way, you can find the angle first by using the cosine rule. Okay, still remember the cosine rule? Here is 15, here is 9, here is 9. This is the angle that we have to find. Okay, by using the cosine rule, 15 squared is equals to 9 squared plus 9 squared minus 2 times 9 cos theta, cosine rule. So you can find your theta is equals to 112.89 degree. Okay, after you find the angle, you can directly find the area of the segment. Okay, so part B, you can directly find your segment by using this formula. Okay, 1 over 2 r squared theta minus 1 over 2 r squared sine theta. So 1 over 2 r squared theta, which is this. Okay, the whole sector. Okay, 1 over 2 r is 9 cm. The theta have to be in radian, so you have to change it to radian. So you have to change it by times pi over 180. So you will get your radian in 1.97 radians. Okay, substitute here 1.97 minus 1 over 2 r squared sine theta is 112.89. So you can get your area of your shaded region is equals to 42.5 cm squared. Okay, so you just directly find your angle by using the cosine rule, then you can find your area of this segment. Okay, they'll have another way. You still remember the notes I tell you about the Heron's formula. Okay, do you still remember how you use your Heron's formula? Just in case you don't want to use this. Okay, let me show you. S equals to, this is the triangle. Okay, I redraw the triangle. Here is 9, 9, 15. S is equals to 1 over 2, 15 plus 9 plus 9, which is equals to 32 over 2. Okay, Heron's formula tells us the area is equals to square root S is 33 over 2. 33 over 2 minus 15. 33 over 2 minus 9. 33 over 2 minus 9. Okay, and then you will get your area as 37.31 cm square. You can find this answer must be same as this. Okay, so you can choose either way to find. If you feel this is more comfortable, then you use this way. If you feel this is more comfortable, then you use this way. Okay? Okay, let's go to another example. Example 4. The diagram shows a sector OPSQ of a circle with center O. So the sector is here, OPSQ. Here is the sector OPSQ with the radius of 12 cm. So here is the 12 cm. Here is also the 12 cm. And the angle is pi over 6 radians. PYQ is a semicircle. So this is a semicircle. This is a semicircle. Okay, oops, I use another color. This is the semicircle. Okay, this is the semicircle with the diameter PQ. Okay, calculate the area of the sector OPSQ. OPSQ. So it wants us to find the sector of OPSQ. So we just directly use the formula. Okay, the sector OPSQ is equals to 1 over 2 r squared theta. Okay, 1 over 2 12 squared. The theta is in radian. So my answer will be 37.68 cm squared. Okay, let us go to the part B. The segment of PSQ. So they want us to find this segment. PSQ. Okay, segment PSQ is equals to 1 over 2 r squared theta, the whole sector minus the triangle. Okay, 1 over 2 r squared sine theta. Okay, the whole sector I already find here, which is 37.68 minus 1 over 2 r squared sine theta in degree. So I have to change the pi over 6 radian to degree. So pi over 6 times 180 over pi. So by deducting it is 30 degree. Okay, so it's sine 30. So I will get my segment is 1.68 cm square. Okay, now we go to the last part, the part C, the shaded region. Okay, the shaded region, that means here is this. Okay, can you see it? Here is the shaded region. Okay, so I had to find the area of the semicircle and then I minus off the segment, then I will get the area of the shaded region, right? So now I have to find the area of the semicircle. So how can I find the area of the semicircle? For a one whole circle, what is the formula for the area? Area of the one whole circle is equals to pi r squared. So the area of a semicircle is equals to 1 over 2 pi r squared. Okay, now we have to find the radius of the semicircle. So how can we find the radius of the semicircle? Okay, so I will draw out this out. Here is 12, here is 12, here is 30 degree. So here is the radius. Okay, here is the radius. So now we can draw it out like this. Okay, I will draw it out like this. Okay, here is 12, here is 15 degree. So here is the radius. Now can we use the sine? Okay, sine 15 is equals to r over 12. So the radius equals to 12 times sine 15. So the radius is 3.106 cm. Now we can find the area of the semicircle already. So 1 over 2 pi times 3.106 squared. So I can get my area of semicircle is equals to 15.146 cm squared. So now can we find the area of the shaded region? Area of the shaded region is equals to 15.164 cm square minus the area of the segment, which is 1.68 cm square, which is my final answer, 13.466 cm square. Okay, so now we go to the example 5. Example 5, two circles with radius 12 cm and 8 cm. Okay, this circle is 12 cm, the radius is 12 cm, and this circle, the radius is 8 cm. Touches each other externally and lie on a straight line CD, shown in the diagram. Find the area of the shaded region. Now you know that here is also the radius, and here is also the radius of B. So what can you see from this diagram? This is a trapezium. Let me draw out the trapezium. Okay. So here is 12 plus 8. Here is 20 cm. Here is 12. Here is 8. Okay. Now this is the area of the whole trapezium. Now this is the sector. This is A, this is B. So if you want to find the area of the shaded region, what should you do? You have to find the whole area of the trapezium and then cut off here, then you can find your area of shaded region, right? So now we have to find the area of the trapezium first. Okay, so the area of trapezium A, B, C, D is equals to 1 over 2 AC, this is C, this is D, plus BD times CD. Okay, so 1 over 2, 12 plus 8 times, then how much is our CD? Do you know how much is CD? We don't know, but we can find. Okay, now we see. Here is the triangle. Can you see? I draw another one. Here is the triangle. Okay, you see, this is a right angle triangle. So I draw out at here. Okay, so this is 20 cm. Do you know how much is here? Here is 8, so here is 8. Okay, so here is 4. Can we know how long is here? Yes, by using Pythagoras theorem. So Pythagoras theorem tells us 20 square minus 4 square. So the square root 20 square minus 4 square is equals to 19.6 cm. So I know that CD is 19.6 cm. Okay, so I substitute here 19.6. Now we can find my area of trapezium is equals to 195.96 cm square. Okay, now we have to cut off this sector and the area of these two sectors, right? So what is the formula of the sector? 1 over 2 r squared theta. Do we have the r? Yes, we have the radius. Do we have the angle? No, both of the sector we don't have the angle. Then what should we do? We have to find it, okay, before we start to find the area. Okay, let me denote that this is theta 1, this is theta 2. We have to find these two angles, okay? So this theta 1, we can use this triangle. This is the theta 1. And then we what can we use? Sine, cos, tangent. We can use cos. So cos theta 1 is equals to 4 over 20. Theta 1 is cos inverse 4 over 20. We can get our theta 1 is 78.64 degree. If in radian, we change it in radian, we times pi over 180 is 1.369 radian. Okay, so can I find the area of this sector already? Yes, we can find already. Okay, but before this, let us find this theta 2 first. Okay, let us find the theta 2. So this theta 2, we know that here is the 90 degree, and we have to plus this. Okay, this small little angle. Okay, we have to plus, which is here, right? Which is here, right? So can we find this angle? Yes, we already know this is 90 degrees, and we know the theta 1. In one triangle, the interior angle is 180. So can we know this angle? Yes, theta 2 is equals to 90 degree plus this is 180 degree minus 90 degree minus the theta 1, 78.64 degree. Then you can know that your angle, your theta 2 is equals to 0.54 degree. Okay, do you know why is this? 180 is the interior angle of the total interior angle of a triangle. Okay, minus of the 90, minus of the theta 1, okay, then you can get your this small little angle. Why I plus the 90? Because here is the 90 degree. Okay, 90 plus this small little one. Okay, then I will get the 101.54. But I want to be in radian form. 101.54 times pi over 180. I will get my answer in 1.771 radian. After you get these two data, can you find the area of the sector? Yes, we can find the area of the sector. Now, we have to find the area of the sector of AC. Let me denote this as E. Okay, so the area of sector ACE is equals to 1 over 2 R squared theta. The theta 1 is 1.369. So 1.369. So the area of ACE is equals to 98.568 cm squared. So now we find the area of DBE. The area of sector DBE is equals to 1 over 2 x squared. The theta is 1.771. 1.771 in radians. So the area is 56.672 cm squared. Now, can you find your area of shaded region? Yes, you can. So the whole area of the trapezium, the area of shaded region is equals to the area of the whole trapezium, 195.96 minus of the area of the first sector minus the area of the second sector. Then you will get your final answer, 40.72 cm squared. So when you look at a question, in your mind you have to plan. Okay, you have to plan. Okay, I want to find the area of this shaded region. So the first thing, I have to find the whole diagram first, the whole trapezium. Then I have to minus off this, then I can get my area of shaded region. So before you find this area, you have to ask yourself, what formula you have to use? 1 over 2 r squared theta. Then you have to ask yourself, do I have the r? Yes, I have. Do I have the theta? No, I don't have. Then you know you have to find. Okay, you have the planning. Okay, after you find this data, then you have to ask yourself, I have to find this. Okay, so I have the r? Yes. I have the theta? No, I don't have. So you can plan step by step. Then you can find your answer easily. Okay? Okay. So we go to the last example of this chapter. The diagram shows the arc PQ and RS of two concentric circles with the center O, such that OP is equal to 2 kcm and OS is equal to 3 kcm. POQ, where is POQ? Here is 5 over 8 radian. So here is 5 over 8 radian. Okay, and the perimeter of the shaded region is PQRS is 33 over 4 cm. Find the value of the K. Okay, we have to find the value of the K. So what information do we have? We have the perimeter of the shaded region. So we know that here is 3K, here is 2K. That means here is K. 2K plus K is equals to 3K, right? So here is also K. Can we find the arc, the length of arc of these two? Yes, we can. So PQ is equals to R theta. Do we have the R? Yes, 2K. Okay, and the theta is 5 over 8. So I can find my answer is 5 over 4k. How about the arc of RS? Okay, RS is the radius, 3k times the radian, 5 over 8. So I can get my answer is 15 over 8k. Okay, so the question tells us the perimeter of the shaded region is 33 over 4 cm. So I know that 5 over 4k plus k plus this one 15 over 8k plus k is equals to 33 over 4. So after I plus it up this, I will get 41 over 8k is equals to 30 over 3 over 4. Now I can use my calculator, divide the 33 over 4 over 41 over 8. I will get my k is equals to 6. You just use a calculator to find the answer, okay? Okay, now we go to the part B. The area of the shaded region. So I want you to find the area of this shaded region. What should I do? I have to find the big area of this, then minus of this small area, right? Okay, how can we find the big area of this sector? We can find the sector, the area of the sector, ORS is equals to 1 over 2, 3k. The radius is 3k. K is equals to 6. 3 times 6 is equal to 18. Okay? 1 over 2 r squared theta. Theta is 5 over 8, which I will get my area is equals to 101.25 cm squared. Now we have to find the small sector, the area of the small sector. Okay? The sector POQ is equals to 1 over 2, 2k. Okay, 2k, 2 times k is equals to 12 cm. And the radian is 5 over 8. So the whole area of the sector POQ is equals to 45 cm squared. So now can you find the area of the shaded region? Yes, you can. So you just directly, the area of shaded region is equals to 101.25 minus 45, which is equals to 56.25 cm squared. That's all for today. So you may use the link below to download the notes. And do remember, like, share and subscribe my YouTube channel. Bye!